Hi, and welcome to the presentation of the paper that we published in SensorComm 2020. In this paper, we are discussing the IMPAQT miniaturized underwater acoustic telemetry platform design, and we are specifically talking about transmitter node system design. My name is Hamed, and I'm presenting this paper on behalf of Marco Belcastro and Brandon O'Fleet. We are a team working at Tyndall National Institute of Ireland, and this project is part of European IMPAQT project. According to the latest estimation by United Nations, by the year of 2015, the world population will reach 10 billion people, and it simply means that we need more source of foods and consequently more source of seafood. And we are seeing that in year 2012, the aquaculture production exceeded the amount of capture fisheries productions. And it means that we are moving from capture fisheries to aquaculture because of its sustainability. To provide such a sustainability in aquaculture farms, farmers need to know more about their farms. They need to know some information, sensor information, environmental information like water quality, like water oxygen levels, and they need to have better insight about their farms, so they will be able to take better decision, appropriate decision at the right time. So IMPAQT is a European project specifically focusing on solving this problem. We are developing some system to generate information and then transfer this information to data aggregator systems and to the cloud at the end. So it enables farmers to monitor their aquaculture sites and take the proper decision at the right time. There are various search activities on building underwater sensors. For example, the JSATS tags are designed to track the movement of the fish in dams, in aquaculture sites, or even in the rivers. Or AquaXL fish beat tags are designed to track the fish respiratory frequency. They design a tag that that it can connect to fish operculum, and then it will track the fish movement and also the fish respiratory frequency. As a part of IMPAQT project and our telemetry platform system, we are developing transmitter nodes which can be attached to seaweeds. They can be floated in the water, or they can be connected to fish cage net, and they can transmit their information using acoustic signals to a receiver gateway buoy, and these gateway buoys can then transmit the data using LoRa, the communication link to inland sites, and from that inland site we can upload the data to the cloud. Each transmitter tag is running on a battery, and it has several sensors inside. It has also an external sensor interface that can be used to attach an external sensor to it. Transmitter tags are using piezo type 6 transducers to transmit the acoustic signals. Piezo type 6 transducers consume more energy comparing to the other piezo transducers, but they also provide a better source level and frequency response compared to other materials. Each transmitter tag is running on a 260 milliampere battery, and we are estimating that based on this table, they can run up to 3 months on a single charge. Each tag is also incorporating a pressure sensor and a temperature sensor, and also a accelerometer. As I told you earlier, it has an IR interface that can be used to connect other sensors to our sensor, and it will collect their information, and it will transmit their information to the receiver, a gateway. Our project is a work in progress, and we are working closely with our colleagues in IMPAQT project to combine their sensors to our transmitter system and provide a better solution to monitor underwater environment. So far, we were able to communicate at 200 bit per second using air transducers with binary phase shift keying modulation, and also we were able to achieve 400 bits per second using on-off keying modulation. Shortly, we are going to test this system underwater, and we are expecting that we will see a huge performance increase since we are going to use 380 kilohertz piezo transducer materials. Our project is part of IMPAQT project, and it has received funding from EU Horizon 2020 funding plan. Thank you for your listening to this presentation.